The question says, the probability of a seed germinating is 1/3. If 3 of the seeds are planted, what is the probability that A, none germinates, B, at least one will germinate, C, only one will germinate? Now, the way to go about it is this. The simplest way is to draw tree diagram. Let's work something out. The probability that a seed will germinate, let's call that G, is 1/3. Therefore, the probability that it will germinate, the probability, because we have either or, probability not germinating, let's call that N, is equal to 1 minus 1/3, which is 2/3. So we can either use tree diagram. So let's start. This is germinate, not germinate. For the first seed, germinate, not germinate. Germinate, not germinate. This is the second. Germinate, not germinate. The third one, you can see. And this is for the second. You can see. So here we have germinate, not germinate. And here we have germinate, not germinate. Now let's look at how it will be for the probabilities. Now this one, we have GGG, that is all germinate. Here we have GGN, only one. And 2 germinates. Here, GNG, 2 germinates. GNN, only 1 germinates. In this place, NGN, only 1 germinates. Here, NNG, and this place is NNN, non-germinates. Now let's go from this place. We can check. The probability that non-germinate is NNN. Okay? Non-germinate is NNN. And that will be 2/3 times 2/3 times 2/3. So that's 2. So it's going to give me 8/27. Easy. Now for B, at least 1 will germinate. At least 1 will germinate, which means we can have the two of them germinate, 1 germinate, or the 3 germinate. So by the time you look at this, it means that it will be 1 minus this one. B. At least 1 germinate. At least, that is 1, 2, or 3. 1 germinates. It will be 1 minus 8/27. And you can also do something like this. Select where at least 1 germinates, like this one, 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 and add everything together. Now for the C part, it says only 1 will germinate. So we will look for where we have only 1 germinating. Here, 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 and that's all. So we are going to have GNN plus NGN plus NNG. And that's going to be 1/3 times 2/3 times 2/3 plus 2/3 times 1/3 times 2/3 plus 2/3 times 2/3 times 1/3. So by the time you look at all of this, you can see you have the same numerator and denominator. So we have 3 times 4/27. So we have this 4/9. Very simple and straightforward. Another way you can do about this is by using the binomial pattern. So let me do it like this. It will be N plus G or Q. So when you do this, it's going to be N cubed here, you can do this thing easily. Non-germinates, you can see. Non-germinates. Okay? It's going to be 2 over 3 raised to the power 3. Now that's going to be 8 over 27. So for non-germinate, it's 2 over 3 raised to the power 3. And that's 8 over 7. For B, at least one germinates. B, at least one germinates. One germinates here, 2 germinates here, 3 germinates here. You can see, because by the time you add all these expansions, it's going to give you 1. So you can just say 1 minus this, or you can say 1 minus the probability that all did not germinate. And it's going to give you 1 minus 8 over 7. Or you can say 3 into n squared g plus 3 ng squared plus g cubed. Depending on how, but for me that one is okay. So it's going to be 3 times 2 over 3 squared times 1 over 3 plus 3 into 2 over 3 times 1 over 3 squared plus 2 over 3 all cubed. So work it out. You are going to get this answer. Sorry, 8 over 27. That's going to give me 19 over 27. So that's for B. Now for C, only one germinates. Where is only one? We have only one germinates. This is the case. You can see, only one germinates here. So you have 3 times 2 over 3 times 1 over 3. So what does that give me? It's 3 times 4 over 9 times 3. That's 4 over 9. So very simple. That's given to me by one of the followers. Those following you. When 3 dice are thrown together, what is the probability of getting a total score of 10? Now, you know that when we throw 3 dice together, we have events of 6 times 6 times 6. That's the total possible outcome. Now, we can draw, for 2 of the dice, that table. After doing this for the dice, we will now take each of the possible events from the box and then draw another one for the third, between the possibility here and the third die. And the third dice. What I mean is this. So what I mean is, you first of all fill the box for 2 dice. After that, you will now take the event here, each, and draw it against the third dice. So you can see, this is the event between the 2, and now against the third one. You can see that everything here we add, you get up to 12. But at the same time, the total that we have here is going to be 36 against 6 here. That is why we have 36 times 6. You can see. So, but if you like, you can go through that, and then you will now count the outcomes that brings 10. From there, you should be able to get your answer. Or you decide and think, how can 10 come about? And this is what I did. How to get 10 from 3 dice? There is possibility of getting 1, 4, 5, 1, 3, 6. You can list all of this. You can list all like this. 1, 3, 6, and 1. Just think of all the possible ways it can come about. By the time you do that, you will count it and then divide it by 6 times 6 times 6. I'm sure you are going to get 27 or whatever there. So with that, you get your answer. You can see I've shown you 2 ways of getting the answer. But some are more tiring, more cumbersome than the other. This one will be more cumbersome than this one. Do you understand? So you just do it like this. 1, 3, 1, 4, 5, 1, 3, 6. Let me see. So you can see. Just list all of them out. possible in any order. The same thing here too. 3, 1, 6, 6, 1, 3. Anyone can come first. But in this place, I can just have 2, 2, 6, 6, 2, 2. I cannot have it in any other way. Okay. 2, 2, 6, 6, 2, 2, 2, 6, 2. Yeah. Here too. Let's see. 3, 5, 2. So here too, I can still have 1, 5, 4. 1, 5, 4. I can have it like that. Just rearrange everything. But when the arrangement is alike, take it as 1. Like if you arrange again and you have 2, 4, 4 here again, you are still having the same thing. So that's what we count as 1. Please take notes. Now the other way I can just go about it is this. Now let's look at how you can get 10. Look at this. Yeah. For me to get 10, I can have 1, 3, 6, 1, 4, 5, 1, let me see. 1, 3, 6, 1, 4, 5, 1, 3. Now let's go to 2. 2, 3, 5, 2, 2, 6, 2, 4, 4. Yeah, 2, 4, 4. And the same way till I get every other one. Now I can still rearrange it like this. I can say 3, 1, 6. Or let me put it like this. 1, 6, 3. I can still make it like that. 1, 6, 3. Or 3, 1, 6. 3, 6, 1. Or 6, 1, 3. 6, 3, 1. You can see there are different arrangements. If I can just select all the right way of getting 10, and at the end of the day, but if I have another arrangement looking like this, I will take them as 1. I will take them as 1. Like after rearranging again, I still get 2, 4, 4 again in the arrangement, because you are bound to have that when you have 2 similar numbers. So you count them as 1, please. Now, with this, at the end of the day, by the time you count all the arrangements, you are going to get 27. If you want it, if you want how I got it, you can connect with your mind on the description. You find the channel in the description below. Now, once you get it, you are going to get something like this. 6 times 6 times 6. So that's the answer you will get. Now let's look at the last way. Now the last one I want to show you is this. I don't say these are the only ways you can do it. The last thing I want to show you is this. The first thing is consider the kind of arrangements that will give you 10. How to get 10. And here we are going to put our knowledge of permutation into use. I can have it 1, 3, 6. 1, 4, 5. Let me see. Now 2, 3, 5. 2, 4, 4. Yeah. 2, 4, 4. Yeah, 2, 5. Okay, 2, 5, 3. Yeah, I got it in 2, 4, 4. I got it in. Now I can also have 3, 3, 4. 3, 3, 4. These are the numbers that can give me 10. Now, if I do arrangement for each of these using permutation, how many arrangements how can I arrange this one? 1, 3, 6, 1, 4, 5. What kind of, how many arrangements will I have? In this place, I'm going to have 3, you have not done permutation and combination before, this might not be clear to you. That's why I'm just saying. So here too, I have here too, 3 times 2 times 1. Here, I have 3 times 2 times 1 over 2 factorial. Because I have two numbers that are similar. Here again, I have 3 times 2 times 1 over 2 factorial. 1, 2, 3, 4, 5. So I can also have this one. 2, 2, 6. So and that's going to be 3 times 2 times 1 over 2 factorial. So let's see, how many is this one going to give me? 6, 6, 6, 3, 3, 3. So this is going to give me total arrangement of 27 if you use permutation and combination. So at the end of the day, probability of getting 10 is equal to 27 over 6 times 6 times 6. And that's going to be, let's see, 3 here is 9, 3 here is 2. 3 here is 3, 3 here is 2. 3 here is 1, 3 here is 2. So it's going to be 1 over 2 times 2 times 2, which is 1 over 8. So that's the probability of getting 10 from 3 fair dice. A committee consists of 6 men and 4 women. A subcommittee is made by randomly choosing 3 of the committee members. What is the probability that A, they are all women, B, 2 of them are men? Now this is situation of combination. Now, or selection. We have total of 10 and we are asked to calculate something. If we are going to choose 3 out of 10, what is the possible, total possible outcome or selection, total possible selection? So we are going to have 10 times 9 times 8 all over 3 times 2 times 1, or 10 6 3. You understand? That is going to be the total possible selection. Now, we are now asked, what is the probability that they are all women? If they are all women, what is the total possible selection? And we are told that there are 4 women. We have 6 men, 4 women. So we are going to have, because we have total of 4 women, the possible outcome is going to be 4 C 3. And that's going to be 4 times 3 times 2 times 2 over 3 times 2 times 1. So the probability now will be this possible selection divided by the total possible selection from all the people. So this is for women only. So the selection for women, that is it. Now total possible selection is going to be 10 times 9 times 8 over 6. You can see. And for this one, it's going to be, let me just call this one. It's going to be 4. Therefore, probability of the committee being women alone is going to be 4 divided by 10 times 9 times 8 divided by 6, which is 4 times 6 divided by 10 times 9 times 8. I would have divided everything straight in, but just waiting. So here I have 2. Here I have 3. So here 3. So everything is going to be 1 over 30. So that's the probability of selection selecting a committee that is only women. Now, for two of them alone, being men, we are going to have it like this. 2 from the men, 1 from the woman. That is 2 men out of 3. Hence, we are going to have 1 woman. Hence, 1 woman. So, what do we have now? We are going to have 6 times 5 over 2 factorial. That is for the men. Times 4 over 1. We are going to have only 1 from the woman. That is for this selection. So we are going to have, this is going to be 3 times 5 times 4. And now the probability of having a selection or a subcommittee that will be 2 men and 1 woman is going to be this one divided by the total possible outcome. That is probability of 2 men. Hence, 1 woman will be equal to 3 times 5 times 4 divided by 10 times 9 times 8 over 3 times 2. This is going to be 3 times 5 times 4 times 6 divided by 10 times 9 times 8. You can see that. So, let's start cut here. 2. 2. Once again, I have 4 here. 3. 1/2. So, the probability of having 2 men is going to be half. 2 fair dice are thrown together. Find the probability that the sum of the outcome is A at least 10, B at most 10, C less than 3, D a total of 7, E at most 5. Because there are so many sub-questions, the best thing is to draw a table about the sum of the outcome, about the sum or the outcomes of the throwing of 2 dice together. So we are going to have something like this. Now this is how the addition table will look like. This is for one of the dice, and this is for the other dice. So you are going to have the sum from 2 to 12. That is the range of the results. Now the first question says at least 10. At least 10. That is the ones with 10 and above. And on counting, we have 1, 2, 3, 4, 5, 6. It's going to be 6. And you can see the total in this square. The total possible outcome is 36. So here, this one and this one is going to be 6 over 36. 1 over 6. Now B. It says at most 10. At most 10. At most 10. That is 10 and everything below 10. So if you look at the ones above 10, it's equal to 3. And then probability above 10 is 3 over 36, which is 1 over 12. Then for less than for 10 and below, probability for 10 and below, or at most 10, is equal to 1 minus 1 over 12, which is 11 over 12. Now, for less than 3, this is the only one. that a total sum of 7, that is, where do we have total sum of 7? We have 1, 2, 3, 4, 5, 6. Total sum of 7 is equal to 6 over 36. 1 over 6. You can see, it's not something that is hidden. Just everything is plain and visible. Now it says at most 5, that is, at most 5, that is 5 and below. 5 and below. So let's quickly count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over 36. 5 over 18. Yes, at most 5. That is what we have for you today in STEM Cafe. So we just treated some questions under probability. That is statistics and probability. So please endeavor to join us anytime, whenever you see the notification of any new lecture. We have a lot in stock for you. Kindly share, subscribe if you haven't, comment, and like. Thank you very much. If you have anything, you can connect us through the description below and assist to let it go viral, please. Any question or if you need more explanation on the ones treated, you can also contact us. And if you have any advice or any criticism, whatever, it's welcome. That is just for our own improvement as well. Thank you. Enjoy this. Have a nice day. And I'm using this opportunity to tell you that we are going to bring in the lecture on statistics and probability. Full one, where we will delve into every aspect of statistics and probability. And I can assure you, you will enjoy it, have fun, understand, and you will be the pride of your school by the time you learn all this. Thank you. Have a nice day.